All right, so here's one more example. Now, this one is definitely going to be more complicated than the rest, but I wanted you to see how, even though it's much more involved than the other problems, that guess and check still can be a workable method. All right, so here's what we've got. Joanne is in charge of ordering backpacks for her camping store, and based on her inventory, the things she already has in stock, Joanne will order 12 more green packs than blue packs, 4 times as many black packs and blue packs, and 2 times as many orange packs and black packs and blue packs together. She'll order a total of 204 backpacks. How many of each color did she order? Use a guess and check table. Now, that whole sentence, that whole paragraph is a mouthful. Okay, but if you take it a piece at a time, guess and check here can still work. Now, here's another reason I picked this problem. There's a lot of different references here to, let's see, we've got green packs, blue, black, blue, orange, black, and blue. What will help here is we're of course going to guess one of these colors to start off with, but again, what will help is if you just kind of take some time to look ahead, that just like we did in this last example where we decided to use width as the guess and not length, here, if you choose wisely, it makes life a little easier. Now, in this case, what I would go with is what color do they refer to the most? In this case, it turns out to be the blue backpacks. So I'm going to guess the number of blue backpacks. Let's say 5. Okay, now I can just follow the process here because everything refers back to the blue packs. So let's take this first one. Joanne will order 12 more green than blue packs. So now from the blue, I can establish how many green packs she's going to order. In this case, 12 more. So 5 plus 12, which turns out to be 17. All right, next, she's going to order 4 times as many black packs as blue packs. So my next column will be the black backpacks, and 4 times as many as the blue. So don't go to green here. Don't do 17 times 4. We're going to go back to the blue. So 4 times as many, in this case 5. So 4 times 5 is 20. All right, and then 2 times as many orange packs as black and blue put together. Okay, so here's where we really have to be careful here. So for the orange, so she's going to take twice as many, so 2 times the black and blue put together. So black was 20, but again, just to stay consistent, I'm going to use the 4 times 5. I'll probably just change this to a bracket. So 4 times 5 plus the blue backpacks, which was another 5, and all that times by 2. 2 times as many. All right. She orders a total of 204 backpacks. All right, so let's total all this up. So let's take the blue, which was 5, plus the green, which was 17. 5 plus 12. And I'm just going to put that in parentheses so we can separate it out from these blue ones. So these 5 in this parentheses is the blue. This is 5 plus 12, that's the green. Black backpacks was 4 times 5. So I've got blue, green, black, and then this complicated one, orange. 2 times 4 times 5, which was the 20 black backpacks, plus 5 more blue backpacks. Okay, do the math on this. Let's see what we get here. 5 and 17, that's 22, plus this 20, that's 42. This turns out to be 50, so 92. Okay, so we're coming up way too low here. All right, so now, again, here's where you might want to pause. Let's write this out a little more clearly. So here's another guess. Last guess was too low, so let's say I go a little bit higher. Let's say I guess 10. All right, so once again, let's walk through this. So 10 blue backpacks. Green is 12 more than blue backpacks, so 10 plus 12. Black backpacks would be 4 times as many as the blue, 4 times 10. And notice how that 10, the original 10, I've coded it in blue so you can kind of see how it fits in with the rest of the problem. And orange, this was kind of the complicated one. So we've got 2 times in these brackets, 4 times 10, which was the black backpacks from here, plus 10, which was the blue backpacks. Black and blue combined, doubled, was the orange. Got 100. Okay, and once again, I've underlined things. So here's the blue. Underlined here, there's the blue backpacks. All this underlined is the green backpacks. This underline is the black backpacks, and all of this is the orange. We're just taking this, this, and this, putting it all together, and we get 172, still too low. All right, here's what the next one would be. Let's say I guess 15. So 15 plus 12, 4 times 15, 2 times 4 times 15 plus 15. Okay, and again, you can see the blue 15 is each time those original blue backpacks. Take all 4 of those, add them all up, too high. All right, so let's take a look at this pattern we've established, and now let's try for the equation. So I chose to do B for the blue backpacks. And all I did was I, again, used this pattern that we found in the table and then used it on this variable B. So in this case, green was just to take the blue and add 12 each time. So that's what I did here, B plus 12. For the black, it was take the blue and multiply it by 4 every time, times by 4. So here, 4 times B. Over here, the orange was to take the blue and the black, so blue and black, blue and black, blue and black, and then double it, times by 2. So that's what we did here. And then the total was just to take blue, green, black, orange, add them up. Blue, green, black, orange, add them up. So that's what we did here. Blue is this one right here. Black is this underlined section right here. I'm sorry, no, that's green. Green, underlined right here. Black was the 4B, which is underlined here. And orange was all of this, which is underlined here. And we wanted that to equal 204. Ignore that too high part. It should just be 204 there. All right, so that is our equation. All right, so now that we have our equation from the last page, let's take it and let's actually solve it. Now, first, I'm going to clean this up a little bit because a little bit of this is just kind of sloppy to read. So we've got blue plus the green, B plus 12, plus the black. This 4B, we don't really need the parentheses, so I'm just going to write it like we're more used to seeing as 4B. And I think I'm going to clean this part up too. This orange is 2 times 4B plus B, which is 204. Okay, that might look a little bit more straightforward. All right, so let's clean this up. Now normally I see these parentheses, I do distributive property here, but I'm also noticing within the parentheses that these are like terms. So let's actually do that first. I'm going to do 2 times 4B plus B, which is 5B. And then over here, I see some other like terms. Let's add those up too. I've got B plus 4B, so that's 1, 2, and 4 more would be 6B, plus 12, which we haven't touched yet, equals 204. Okay, so I didn't do distributive property here because I saw that within the parentheses I could just add that all up. Over here I just took these like terms and put them together, and the 12 is the only quote-unquote normal number that we just didn't touch yet. All right, let's go a little further here. So we got 6B plus 12. This part would simplify further, 2 times 5B, which would be 10B. And then if we go even further with that, we've got some like terms there. We've got 6B and 10B, which would total out to 16B plus 12 equals 204. All right, now I can think roadmap here. In this case, the roadmap would tell me to get rid of this 12 first, so I'd subtract 12 from both sides. I'd get 16B equals 192. And then we divide both sides by 16. So blue backpacks would be 192 divided by 16, turns out to be 12. All right, so there's 12 blue packs. All right, and the original problem asked for all of them. So let's go back to this problem because it's underlined nicely here. We can see everything. So that takes care of the blue. For the green, it was B plus 12. So this plus 12 would be 24 green packs. Oops, having some trouble there. Green. For the black backpacks, it was 4 times as many as the blue, so 12 times 4 is 48. And then the orange. Now the orange here would be the blue and the black put together. This 4B and 2B put together. So 12 plus 48, that's 60. And then 60 times 2, that's 120. So 120 orange packs. All right, so as you can see, that was a long involved problem, but I wanted you to see that because it doesn't matter if the problem's more straightforward like Tito's Guess My Number problem, or something super complicated like this where you've got 4 different colored backpacks being added together. That guess and check can be used as a strategy for all those, especially when it comes to coming up with this equation.